Chapter 12.3, Surface Area of Pyramids and Cones. A pyramid is a polyhedron in which the base is a polygon and the lateral faces are triangles with a common vertex called the vertex of the pyramid. The intersection of two lateral faces is a lateral edge. The intersection of the base and a lateral face is a base edge. The height of the pyramid is the perpendicular distance between the base and the vertex. Okay, so here's the drawing of a pyramid. And we see the lateral, we see the lateral faces are triangles, okay? So you can trace the triangle right here. The lateral faces are just triangles. All right, the base right here can be any polygon. And where the lateral faces intersect each other right there, that's called a lateral edge. And where the lateral faces intersect the base, that's called the base edge. And finally, all the lateral faces meet at a point called the vertex. A regular pyramid has a regular polygon for a base, and the segment joining the vertex and the center of the base is perpendicular to the base. The lateral faces of a regular pyramid are congruent isosceles triangles. The slant height of a regular pyramid is the height of a lateral face of the regular pyramid. A non-regular pyramid does not have a slant height. Okay, so here is a regular pyramid, and the base of the regular pyramid is a regular polygon. All right, so for the base on a regular pyramid, all the sides and all the angles of the base are congruent. Notice the height starts at the vertex and it goes straight down inside the pyramid and it is perpendicular to the base. And the slant height is actually the height of one of the triangular faces. So the height and the slant height are two different things. So remember, the slant height is the height of the triangle. All right, and the height inside the pyramid is different. That's the height of the actual pyramid. Those are two different things. Also, it was said that these triangles are isosceles triangles for a regular pyramid. Okay, so the sides, two sides of the triangles are congruent, and actually going all around the pyramid, all these triangles are congruent. Example 1, a regular square pyramid has a height of 15 centimeters and a base edge length of 16 centimeters. Find the area of each lateral face of the pyramid. Okay, they said the height of the pyramid is 15 centimeters. So that starts at the vertex of the pyramid and runs inside the pyramid, and it is perpendicular to the base. Now, they said that the base edge is 16 centimeters. So if we were to draw a right triangle inside the pyramid, we would have this distance here. That's the height, and that's 15. And we would have this distance here, and that's half the base. How do we know that? Because the height inside the pyramid goes right into the center of the base. Okay, so this distance here is just half of the base, and we can see the base edge, I should say base edge right here is 16 centimeters. So half of the base is just going to be half of 16, which is just 8. All right, so this edge right here, or this segment, is just 8. And in order to find the slant height, which we call L, we have to construct a right triangle inside the pyramid. So this right here, this is a right angle right here. This right here is the right triangle that we are working with. In order to find the slant height, we need to use Pythagorean theorem. Okay, so of course that's just a squared plus b squared equals c squared. Okay, across from your right angle is your hypotenuse. That's always going to be C. The other two sides are A and B, so I'm going to let A equal 15, and I'm going to let B equal 8. All right, this B is just in the Pythagorean theorem. This B is actually a base edge. Anyhow, A squared is going to be 15 squared. B squared is going to be 8 squared. And C squared is your slant height. That's L. And that's L squared for C squared. Okay, 15 squared plus 8 squared. That's going to be 289, and that equals L squared. And opposite of squaring something is to take the square root of both sides. Square root of L squared is just L. And the square root of 289 is just 17. Now, that's not what they asked us. They asked us for the area of each triangle. So I'm going to erase what I did so far. Now, let's see. We know the area of a triangle. Area of a triangle, I just drew a triangle symbol, is going to be 1/2 base times height. So that's going to be 1/2. The base of this triangle is this right here, but they gave that to us already. B is 16. And the height of this triangle is right here. That's the slant height. We can call it H at this point because it's the height of this triangle. So in place of H, I'm going to plug in 17. All right, half of 16 is just 8. And 8 times 17 is going to be 80 plus 56. That's 136. The units are in centimeters, so for the triangle area, that's going to be centimeters squared. So that is basically each triangle. Okay, moving on to surface area. A regular hexagonal pyramid and its net are shown at the right. Let B represent the length of a base edge and let L represent the slant height of the pyramid. Okay, so right here we have a hexagonal pyramid. See that all the triangles meet at a point, so it's a pyramid, and the base is a hexagon. So one side of that hexagon is lowercase b. Okay, and remember the slant height runs along the side of one of the triangles, right down the center of one of the triangles. Okay, so that right there is your slant height, L. So we can find the area of each triangle just like we did in the first place, in the example 1. The area for each triangle is going to be 1/2 base times height. So that's going to be 1/2. The base is lowercase b, and the height h is just L. So recall when we did prisms, we called the area of the base, we called that capital B. Okay, so capital B is just going to be the area of the base. And if we wanted to find the surface area, we would do the area of the base, which is capital B, plus the area of all these triangles. Okay, we just said a minute ago that each triangle, the area is 1/2 BL. Now, how many triangles are there? Well, this is a hexagonal base, so we have 1, 2, 3, 4, 5, 6 sides. We have 6 triangles. So we take the area of the base and we add the area of the 6 triangles, so that's going to be 6 times 1/2 BL. Now, if each side of this hexagon is lowercase b. The perimeter for the hexagon is basically just going to be 6 times b. Okay, the hexagon has 6 sides, and each side length is b. So the perimeter for the hexagon is just 6b. So for the surface area, we have capital B, and we said 6 times b is the perimeter. So 6 times b, these are all multiplied. We can cancel the 6 times the b and call that perimeter. And then we're left with 1/2 times L. So that's going to be perimeter times 1/2 times L. I should have put a plus here, not an equal sign. So that's a plus. And finally, surface area is going to be capital B plus 1/2 PL. And that is the formula for the surface area for a pyramid. So notice here they unfolded the pyramid. That's just called a net. The hexagonal base area is capital B. The length of one of the sides of the hexagon is lowercase b. And we know the slant height is the height of one of the triangles. So that's it. All right, the surface area S of a regular pyramid is S equals B plus 1/2 PL. Capital B is the area of the base. P is the perimeter of the base, and L is the slant height. This is for a regular pyramid. B plus 1/2 PL. Example 2, find the surface area of the regular hexagonal pyramid. Okay, we said a minute ago the surface area for the pyramid is going to be capital B plus 1/2 PL. I'm sorry, that should be a capital P. The P stands for perimeter anyhow, but they use capital P. Okay, B is the area of the base. They said this is a regular hexagonal pyramid. Regular means all the angles and sides are congruent on the base. So this side matches this side, matches this side, and so on. We know the area for a regular hexagon is 1/2 apothem times perimeter. And that's going to be plus 1/2 perimeter times L. Okay, so we have 1/2. The apothem is A. It runs from the center of the hexagonal base to the center of one of the sides. How do I know this is the center of the side? Well, it makes a right angle right here. Okay, and this right here is an isosceles triangle because it's a regular base, a regular hexagon, and they drew in the radiuses, so this radius matches this radius. So it's an isosceles triangle. When you draw the height inside and it's perpendicular to the base, it bisects the base. Anyhow, this is clearly the apothem because it starts here and it's perpendicular to the base. So the apothem is 5 radical 3. All right, so in place of A, I'm going to put 5 radical 3. And we know the formula for perimeter is just N times S. N is the number of sides. It's a hexagon, so that's 6. S is the length of each side of the hexagon, so that's 10. All right, so for perimeter, I'm going to write 6 times 10 in place of P. And now, I'm going to have to do that again. 1/2 perimeter is going to be 6 times 10. And the slant height L they actually gave us. We don't have to do Pythagorean theorem this time. It's this distance right here. So that's your slant height L. So in place of L, I'm going to put a 14. Now, they didn't say to round or whatnot, but I can see their final answer is 2 decimals. So that's what I'm going to do. So I'm going to do this whole thing on the calculator. For the 1/2, you can enter 0.5, unless you know how to do fractions on your calculator. So I'll do 0.5 times 5 times the square root of 3 times 6 times 10 plus 0.5 times 6 times 10 times 14. Hit equals, and I get 679.807. Okay, and if I were to round to 2 decimals like them, I would just look at the 3rd decimal. If it's 5 or more, you round it up. So I'm going to say 679.81. All of the units were in feet, so the units on the area, or surface area, are going to be feet squared. So that's your final answer. And right here, they just showed you the hexagonal base by itself. But all of these measurements were in the original diagram. Okay, so they're just showing you the base right here. And remember, capital B is the area of the base. And for a regular polygon, the area is 1/2 apothem times perimeter. So that's what we used in the formula in place of capital B. Okay, guided practice number 1. Find the area of each lateral face of the regular pentagonal pyramid shown. Let's take a look. All right, so here's the diagram. This here is the height H, but that's the height of the pyramid. All right. You need to construct a right triangle right here. Use this right triangle and find this side length, or should I say slant height right here. That's L. Okay, use Pythagorean theorem to find L. Once you do that, that's going to be the height of one of the triangles. Okay, you can see the base of each triangle is 8 meters, and then use this as the height of the triangle. Remember, the area for a triangle is 1/2 base times height. So see if you can get the area of each triangle. Okay, in order to get this slant height, L, we have to use this right triangle that is actually inside the pyramid. So this distance right here is 4.8. Well, let's use the Pythagorean theorem. We go across from our right angle. Okay, that's your hypotenuse. So L, the slant height, is going to be C. A and B, it doesn't matter which is which. I'll let this height equal A, and I'll let this equal B. So for A squared, it's this right here. That's going to be 4.8 squared. For B squared, that's going to be this distance here. That's 5.5 squared. And C squared is this distance here. That's going to be L squared. Now, you can do this on the calculator, but really you can do the whole thing in one shot. Okay, we have L squared. The opposite of squaring something is to take the square root. So I'm just going to take the square root of this whole thing right here. Okay, so square root of 4.8 squared plus 5.5 squared is 7.3. So that's my slant height L. Let me erase this mess. All right, slant height L is 7.3. So that's this distance right here. Okay, that's going to be the height of the triangle. 7.3. We're looking at, just to highlight it for you, we're looking at this triangle right here. All right, all the triangles are the same because it's a regular pyramid. All right, so the side length, this height is 7.3. And the base right here, we can see right here, it's 8. So the base is 8. All right, so the area for each triangle is 1/2 base times height. That's going to be 1/2 base, so that's 8. And the height is 7.3. Okay, so I'm just going to go right to the calculator. Even if you cancel, we know 1/2 of 8 is 4, but I'm going to need the calculator. 4 times 7.3 is going to give me 29.2. Okay, all of the units were in meters, so the units for an area, it's going to be meters squared. Okay, problem 2. Find the surface area of the regular pentagonal pyramid shown. Okay, you can use the formula for surface area if you want. However, we already found the area for each triangle. So all we have left for surface area is the area of the base. And then since this is a pentagon, it's going to be 5 times the area of each triangle, which we already found. So use 1/2 apothem times perimeter for the base and 5 times the area of each triangle, and you'll have your surface area. Okay, so for the base, capital B, that's the area of the base right here. That's going to be 1/2 times the apothem, which is this distance right here. That's 5.5. Well, let me write it out first. 1/2 apothem times perimeter plus 5 times the area of each triangle, which is 29.2. All right. So that's going to be 1/2 times the apothem, which is right here, 5.5. And the perimeter, this is a pentagon, so there's 5 sides. They're all congruent. Okay, we see that each side is 8. And the perimeter is just going to be n times s, where n is the number of sides. It's 5 sides, and each side s is 8. So the perimeter is just going to be 5 times 8 in place of p. 5 times 8 plus 5 times 29.2. And let's see. You can do 1/2 if you know how to do fractions, or you can do 0.5. All right, 1/2 times 5.5 times 5 times 8 plus 5 times 29.2, and I get 256. Once again, all the units were in meters, so the units on an area are going to be meters squared.